May I call upon the next presenter for the paper towards automated PKI trust transfer for IoT, the author Joel, Mr. Martin Sahed. Can you join? Hi, Joel. Can you share your presentation, please?
To enable screen sharing then. Currently screen sharing is, let's see, hang on.
From your end.
So is it correct now?
Perfect.
Yes, I'm sorry for the delay. It's this with multiple screens, it's always a bit of a hassle. So, okay, back to the agenda. And we have already heard many interesting talks about both the needs for new crypto algorithms and for questioning the PKI system in general. And this, I believe, fits nicely into and addresses some of these issues. In a nutshell, let's see. In a nutshell, I will be presenting how the control of an IoT device can be securely transferred between different service providers using standard-based technologies and a minimum of human intervention. And there will be some little background, but I will skip most of it since we are short on time and we have heard through the previous talks most of this material since before. But let's quickly step through the material. And starting specifically with our challenges. IoT deployments are often tied to single service providers as of now, and this creates vendor lock-ins and risks blocking development when for the big rollout of IoT for critical services if the IoT owners are not certain that they will be able to get the proper support for their deployments. And in fact, even though it might be already theoretically possible, there are no practical solutions to securely switch service providers because of administrative and economical thresholds stemming from the manual labor involved. So what we are trying to do, to find a minimal procedure in terms of manual intervention to securely shift the operation of one IoT device from one service provider to another. But to do this, we need to be aware of the general challenges revolving PKI for IoT. And as mentioned, I will step through them briefly since we heard most of it already before. Scale is one. This is well known by all in the audience, I hope. And for IoT, of course, still resource constraints. One can argue they are becoming more powerful. And yes, that's very important because this means we can use also asymmetric crypto operations, but because of cost and energy constraints, there is always the need to be as efficient and as constrained as possible to be able to use the cheapest available hardware that meets the security requirements. And this is a bit for fun, but it's illustrating that it is a jungle out there. There are many services, many standards which are now evolving relevant to the IoT field. But it's a very heterogeneous landscape that takes time and energy to navigate. But this is the direction that must be pursued if one wants to have actual industry impact to go for the standards that we believe to be relevant for the upcoming future. And as we see the last couple of years, we are now getting fundamental building blocks in place when it comes to IoT security. And this goes both for the lower level actual crypto algorithms available, the encodings of the protocols, and more higher level services such as actually being able to do certificate enrollment also for IoT constrained devices. So looking at the problem scenarios to actually shift the control from one service provider to another, in practice, this means that an IoT device, which was previously in the in the PKI realm of one service provider belonging to one certificate authority might need to switch completely to another branch belonging to another certificate authority. And a protocol that should be generic must handle all these different possibilities. So this is also then to illustrate some of our assumptions. An IoT device needs to have a factory certificate which is believed to be valid for the lifetime of the device. And that, of course, must be issued by some CA which is believed to be around for a long time and not just going in or out of business. But this certificate should be extremely limited in terms of reach. It should basically only be used for initial authentication to do the enrollment operations. To actually have an operational certificate, it should have another certificate with more powers or more fine-tuned settings to grant IoT device the specific rights it should have within a specific organization. And all this needs to be taken care of if the control is to be transferred from one service provider to another. So, one moment. So, with all this in mind, let's look at some of the security requirements that such a protocol needs to fulfill. And these are, of course, in a way, standard requirements for most secure protocols, but it's important to state them clearly to make it whole also for this transfer protocol. It should not be possible to impersonate any legitimate device or any other involved party. It must not be possible to replay captured messages and get undesired side effects. And here we come to what we are actually talking about, switching between two entities. And both forward and backward security are highly relevant, that the other party should not get access to any of the data that is not intended to be shared by the other party. So, but this is not enough for IoT. We must also be explicit with some non-functional requirements in order for this to be actually feasible and usable in practice. And those are, of course, automatization, to minimize the human intervention, and to be sufficiently resource efficient. And for industry usage, it must be either building upon existing or proposed, believed to be standard solutions. So where does it fit in a IoT life cycle? This could be a long talk in itself, but here is a quick overview of the IoT life cycle blocks. And it starts, of course, with a customer having actual needs, which needs to be negotiated. So this is basically to highlight that there are also manual contractual agreements in terms of that the owner needs to encode the desire that a service provider must be able to perform these kinds of operations. That is basically to say that, yes, they need to provide support for this protocol. Otherwise, it would not be feasible to retrofit it. We have already talked about enrollment to actually get the operational certificate, and thereafter to be a normal entity within the owners and service providers' domains. And here, of course, it could stay for the entire IoT lifetime if the owner and customer is happy with the service provided. But it might be the case that at some point, the owner decides to actually request a change of operator. And this is where our protocol comes into play. And then based on the previous agreement, there must be then links to be links established between the previous service provider and the next in line who is about to take over the control. And I won't go into the exact details of all of these exchanges, but some of the main take-home messages is that through the use of certificates and a public key infrastructure, it is possible to securely transfer the identities of the new identities, which should now transfer from the realm of service provider 1 to the realm of service provider 2. And this, besides sharing the actual factory certificates, we also highlight some of the other messages in terms of transfer message and update info list. Let's have a little look at those as well. So this is in the device update info. Here we also propose another reference to upcoming standards, because if the device is actually to be kept live and running for this transfer operation to happen, it's extremely important that the new receiver knows exactly what software will be running on the device. And one way of solving this is by references to the suit manifest protocol way of handling software versioning. So this is still a work in progress in the suit working group, but this we believe to be the relevant for the future way of actually pinpointing software versions on IoT. And then the message that actually will be sent to the IoT device will be a specific transfer message with the updated fields needed. So for instance, optionally to do remote attestation, and possible then for software specific updates, and the most crucial one, where to go to do the new enrollment with a potentially new certificate authority. And these messages then are signed by the agreed service provider keys and can be validated by the IoT device before they take any action. So this is then again to show that the transfer message, after the validation of the transfer message, the IoT device will reset to a agreed software state. It will potentially do participate in remote attestation, and then it will re-enroll with a new certificate authority to get a new operational certificate. And once this is successfully completed, the transfer of trust is done, and it is now a functional member of the service provider 2 realm. So let's look at our feasibility study, because again, to be feasible for IoT, this must be possible to do with limited overhead. And all of these messages involved, which goes actually to the IoT device, are in total smaller than just a regular DTLS-based certificate handshake. So it's clearly something which is affordable in terms of messaging. And same with the computational overhead for devices that are capable to perform asymmetric crypto for the handshake. This is just one extra signature verification for the crucial transfer message. And we have, in our test implementation, we are reusing the crypto libraries that are still needed, or anyhow needed, for doing the ad hoc session establishment and for OSCORE application layer security. But here is also good opportunity to highlight that, yes, our solution could work with DTLS-based security, but we are strongly advocating the more lightweight and more customizable application layer security solutions that are now becoming mainstream for IoT, because they have in total both lower memory overhead, if done properly, and lower computational overhead, and can also reduce the messaging sizes. So we have done an initial security requirement analysis to check that with our setup, since the end-to-end communication will be encrypted using mainly OSCore as our main proposal. And this is a good reference then to a previous speech that yes, we are assuming authentication equals authorization for some of these operations, that if the IoT device is capable of authenticating itself, it can then be authorized to be part of this protocol. Plus, of course, the explicit sharing of factory certificates between some of the server endpoints. This together prevents any impersonation attacks. And with the used protocols, there will be sequencing numbers that will prevent man-in-the-middle attacks and will make replay attacks detectable. And as long as the enrollment is successful, the re-enrollment with the new certificate authority, there is no way to break forward security. And when it comes to backward security, that of course depends on what the node will keep in its software state. So it's up to the initial service provider to actually decide themselves which software they will leave running and how potential company secrets should be deleted before the transaction happens. Okay, so those were the security requirements. And most of this is basically already answered in the feasibility study, but it's worth highlighting that in today's ecosystem, individual certificates are on the costly side. So there is still the need to push more and more optimization to make these kind of scenarios economically feasible for hundreds and thousands of devices. And when it comes to resources, that's the feasibility study. And finally, when it comes to standards, all this has been built with standard building blocks.
Joel, sorry to disturb you. Can you make it fast?
Yeah, this is the end. Yes. So this is wrapping up, saying that we are now proposing a modular protocol for secure trust transfer using existing and upcoming standards. So thank you very much.
Thank you. Thanks for delivering such a wonderful talk. Is there any queries from the audience side? Yeah, Professor Shyam Sundar has some queries. Sir, please, Mike.
I have a question. Is the IoT requires a delegate? The IoT, will it require as a delegate operation?
Joel, question over to you.
I think
So can you repeat?
this one is being done parallelly, so he is getting confused.
Sorry?
I wanted to know, one is if the IoT can be decentralized in giving certificates, or IoT has the capability to delegate its role, then what happens?
So we are not really addressing the issue of delegation. We are assuming that the certificate authorities are capable of interacting directly with the IoT devices. And but there are ways of delegating, for instance, some of the CA capabilities directly to the service provider. And this should work without changing the assumptions for the protocol, but we have not done it explicitly.
Joel, these
Yes,
crypto
yes.
libraries, ad hoc and OSCore, have you developed? It's an open source.
Some of the modules are open source. Our actual protocol is not yet released as open source. We are looking into ways of actually doing formal verification for part of it. So we hope to release at least part of it. But currently, several of the modules are available through the Contiki operating system, but not the actual protocol. But we are looking into it for the future.
If you say there is a replay attack resistance is possible in the combination of TLS, DLTS, and OSCORE, then what is the other combination you have been tried out for the resistance?
No, so the two combinations I was mentioning is either TLS plus DTLS, which is kind of the older and in a way more available, but also more resource heavy. The one we are proposing is TLS for internet-based server-to-server plus OSCORE and ad hoc when it comes to the IoT devices. Those are the two setups.
I hope you have a long journey to carry out the further attacks.
The further attacks? I'm sorry, I didn't catch.
You have a long journey to carry out further more attacks resistance, right?
I'm sorry, I'm not really getting the question.
No, I'm saying it. There are some more attack has to be resistance, so that you have to combination of all other crypto libraries has to be carried out. So that is still lagging.
So there are, but we are in verifying the point-to-point connections one by one to see that they all hold. Okay. But I would be happy to discuss either offline or if you have some more specific.
No specific, but still there are more resistance to attack has to be carried out. Thank you.
Thank you.
We'll call upon the next speaker for the PKI for IoT using DNS infrastructure.